Another classification of chemical reactions is based on the reaction pattern. That is, on how atoms and groups of atoms rearrange during the reaction. The first type of reaction in this classification is a synthesis or combination reaction. In synthesis reactions, two reactants come together to form one product. Examples of such reactions are the formation of sodium chloride from solid sodium and chlorine gas, or the formation of calcium carbonate from calcium oxide and carbon dioxide. The second type of reaction in this classification is a decomposition reaction. Decomposition reactions are the opposite of synthesis reactions. In them, one reactant falls apart to form two products. An example of such a reaction is the electrolysis of water, the decomposition of water into oxygen and hydrogen gas by passing an electric current through the water. Another example is the decomposition of calcium carbonate into calcium oxide and carbon dioxide when it is heated, the opposite of the second synthesis reaction that we looked at. The third type of reaction in this classification is a single displacement reaction. In this type of reaction, an atom or a group of atoms replaces another atom or group of atoms in a compound. One example of such a reaction is the displacement of copper in copper-2 chloride by zinc that leads to the formation of zinc-2 chloride and the recovery of elemental copper. Another example is the formation of sodium hydroxide in the reaction between sodium metal and water. In this reaction, a sodium atom replaces one of the hydrogen atoms in a water molecule to form sodium hydroxide. The hydrogen atom that is released pairs up with a hydrogen atom that is released from another water molecule to form a diatomic hydrogen molecule. The fourth and final type of reaction in this classification is the double displacement reaction. We have already seen a number of such reactions when we talked about reactions between compounds in aqueous solutions. One example is the reaction between silver 1 nitrate and sodium chloride that leads to the formation of silver 1 chloride and sodium nitrate. It is a precipitation reaction because one of the products, silver chloride, is insoluble in water. It is also a double displacement reaction because the cation from the first reactant, Ag+, replaces Na+ in the second reactant and combines with the anion from the second reactant, Cl- to form silver 1 chloride. At the same time, the cation from the second reactant, Na+, displaces Ag+ in the first reactant and combines with the anion from the first reactant, NO3-, to form sodium nitrate. Another example of a double displacement reaction is the neutralization reaction between hydrochloric acid and sodium hydroxide that leads to the formation of sodium chloride and water. Just like for the previous reaction, the cation from the first reactant, H+, displaces the cation from the second reactant, Na+, and combines with the anion from the second reactant, OH- to form water. At the same time, the cation from the second reactant, Na+, displaces the cation from the first reactant, H+, and combines with the anion from the first reactant, Cl-, to form sodium chloride.